Yes, friends, good morning everyone. Okay, let us discuss what are the questions given in GATE 2022 in electrical paper. Okay, previously we have discussed electronics paper. Okay, let us see how they are given. What is standard of the questions? My opinion, this paper is easy or moderate, that's all, not difficult paper, straightforward, everything. Okay, let us see what are the questions given in GATE 2022. And this video I am shooting based on the inputs received from the students. Okay, what are the questions? These are memory based questions. Actual GATE paper not released. Officially it will be released in maybe in a week or couple of weeks. Okay, right. See, let us see some of the questions what are given. Okay, here if you observe here, they given one circuit diagram. Okay, this question is from network theory. Right. In the circuit shown, the switch is closed at t equals 0. The magnitude of the steady state voltage in volts across 6 ohm resistor is they are asking. Okay. Here simple, nothing is there. Okay. Don't get panic by seeing those switches. In the circuit shown, the switch is closed at t equal to 0. Okay. Before t equals 0, it is open for a long time, and at t equals 0, it is closed. The magnitude of the steady state voltage, okay, magnitude of the steady state voltage they are asking, that's all. Everyone, simple point, irrespective of the initial conditions at steady state, inductor behavior, short circuit behavior, capacitor behavior, open circuit behavior, irrespective of the initial condition in steady state, okay, inductor behavior, short circuit behavior, capacitor behavior, open circuit behavior, that's all. In this question only capacitor is given, they are asking. Okay, right. First of all, draw the circuit which is valid for all time t greater than 0. For all time t greater than equal to 0, okay, this switch is closed. This switch is closed at t equal to 0. For all time t greater than 0, this switch is closed. For all time t greater than equal to 0, switch is closed. Right. Right now, let us go to steady state. Okay, steady state. Let us move on to steady state. In steady state, okay, as t tending towards infinity, this switch is closed for a long time, which is closed at t equal to 0 itself, right? And this DC source, this 10 volt source, DC source, it is connected to the network containing capacitor for a long time. And this capacitor charges to maximum value, beyond that one everything constant. Then in steady state, this inductor behavior, short circuit behavior, capacitor behavior, open circuit behavior. Okay, open circuit. In steady state, this capacitor opens. If I redraw this diagram again, okay, if I redraw this diagram, okay, this 6 ohms, 3 ohms both are parallel. Okay, I can show like this. This 6 ohms here, this is 3 ohms here, both are parallel. 6 ohms, 3 ohms parallel. And this capacitor is open circuited. This capacitor open circuited. This is a 10 ohm resistor. Okay, this is a 10 ohm resistor. And here this is, okay, this is 10 volt source, 10 volts. This is a 2 ohm resistor. In steady state, this is the circuit that is valid. Capacitor behavior nothing but open circuit behavior, irrespective of the initial condition stored before t equals 0. This capacitor behaves like a open circuit, that's all. And what they asked us in the question, determine, okay, the magnitude of the steady state voltage across the 6 ohm resistor. Okay, they are asking us to determine the magnitude, just the magnitude, not the polarities. Okay, what's the voltage across this 6 ohm resistor? Voltage across this 6 ohm resistor, maybe plus minus or minus plus. Okay, what is the voltage across 6 ohm resistor? V 6 ohms. At steady state they are asking infinity. Okay, what is this voltage across this capacitor in steady state they are asking. Okay, this is minus, this is plus, let this be V 6 ohms at steady state, that's all. Simple, nothing is there. Okay, here open, no current flows across this one, 0 amperes, open terminals. This resistor does not have any significance here. Okay, right now this 3, 2, 3, 6 both are connected in parallel. What is 3 parallel with 6? 3 parallel with the 6. What is value? 3 into 6 by 3 plus 6. Okay, 3 into 6 by 3 plus 6, 8 by 18 by 9. What is value? 2 ohms. 2 ohms. This is equivalent nothing but 2 ohms. And here, what is the current supply by source? Let us find out. Right now, this is 2 ohms. This also 3 parallel with 6. This also 2 ohms. Okay, this is minus plus 10 volts. Then what is the current supply by source here at steady state? Current supply by source nothing but total voltage by total resistance. What is I? This I nothing but 10 by 2 plus 2 or 5 by 2. 2.5 amperes, 5 by 2. Okay, right. This current supply by source nothing but we got 5 by 2 amperes. Okay, this also 5 by 2 amperes. This 5 by 2 amperes seeing 3 ohms and 6 ohms. How they connected to each other? Both parallel. Current division rule. Tell me what is the current flowing? Right now 3 and 6 are parallel. Current division rule. Current division rule. CDR. Tell me other rest. I want the current in the 6 ohm resistor. What is the current in the 6 ohm resistor? Tell me. Current in the 6 ohm resistor. Other resistor. Okay. 3 by 3 plus 6 into total current 5 by 2. Okay, this is right 3 into 15 divided by 2 into 9, right? Okay, right, this is 3 threes, this is 5 by 6 amperes we got here. That's the current in the 6 ohm resistor. What they asked us to determine what is the steady state voltage across the 6 ohm resistor. Therefore, let us find the steady state voltage across the 6 ohm resistor. Tell me. Therefore, steady state voltage across the 6 ohm resistor is nothing but Ohm's law. Ohm's law. Just apply Ohm's law. V equal to IR. What is V equal to IR? This is 6 into current in the 6 ohm resistor. Okay. This is 6 into what is current in the 6 ohm resistor at a steady state we found out here. Okay. At steady state, this is the current. Okay. 5 by 6. Therefore, this is 6 cancel 5 volts. Steady state voltage across the resistor nothing but 5 volts for the given circuit. Okay, simple. Only thing you require to know to solve this question is steady state behavior of capacitor. Steady state behavior of capacitor is nothing but a open circuit behavior. That's all, right? Let's move on to the next question. What is the information given here in the circuit shown below? The magnitude of the voltage V1, okay, in the circuit shown below, the magnitude of the voltage V1 across the 8 kilo ohm resistor is rounded off to the nearest integer. Okay, what is the magnitude of the voltage across the 8 kilo ohms they are asking, right? This is the network given. If you notice the elements present in the network here, 75 volt source, 2 kilo ohm resistor, this is a dependent source, depends on V1, 0.5 V1, and this is a dependent current source. This is a dependent voltage source, the current dependent current source, and this is 8 kilo ohm resistor. Voltage across this one is V1. Okay, this voltage, this is controlled by voltage V1 here. This is controlled by current here I. Okay, right. Right now, let us see. See here, suppose this is current I. Okay, if we are assuming this is current I. This is I. Right, this I seeing two paths. This I seeing two paths. This is one path. This is another path. Both are parallel paths. This is one path. Okay, this is another path. Both are connected in parallel, and one of the path is shorted. Okay, current always chooses the minimum resistance path or short circuit path. Okay, whatever the current here, the same current will be circulating here itself. Okay, short, right. Okay, right. Similarly, this current source and this resistor are in series. Can you please tell me this current is I? What is the current? What is the drop across this 8 kilo ohm resistor? Ohm's law, tell me. V equal to IR. Okay, this is 8K into I. That's all. 8K into I. That's the V1. V1 for the given problem nothing but 8K into I. 8K into I. voltage V1, okay, nothing but 8k into I. Right. Okay, let us apply KVL for this loop. Tell me KVL for this loop. If you apply KVL for this loop, what is the KVL for this loop? Tell me KVL for this loop. Minus 75 plus 2k into I, 2k into I plus 0.5 V1, 0.5 V1 equal to, no, nothing is there, 0. Okay, that's all simple. Okay, if I know I can find V1, or if I know V1, I can find I. Okay, simple. Let it be equation 1, let this be equation 2. Let us substitute 2 in 1. First of all, find that I. Minus 75 plus 2k into I, okay, plus 0.5 into V1. What is V1? 8k into I equal to 0. 8k into I equal to 0. Right, this is 0.5 into 8, 4k plus 2k, 6k. That implies 6k into I, okay, equal to 75. Then I equal to 75 by 6k. Okay, let it be 3. Let us find, okay, let us substitute 3 into, okay, V1. What is V1? 8k into I. What is I? 8k into 75 by 6k. K cancel, okay. 8 into 75 by, cancel it here, calculator, just 3 25s, 3 2s, okay. This is 3 2s, 3 25s, 2 4s, okay. 4 into 25, this is 100 volts. That's all. That's the value of V1. That's the value of V1. That's all, finished. Nothing is there. Only thing is, it seems like a little complex network by seeing the dependent sources present in the network. Okay, simple, finish, done. Okay, next, the easiest question in GATE 2022. Okay, the network shown below has a resonant frequency of 150 kilohertz and a bandwidth of 600 Hz. The quality of the network is dash. They are asking what is the quality factor of the network. Simple. What is the information given? Resonant frequency of naught. This is given as 150 kilohertz. Okay, and bandwidth is given as 600 Hz. What they are asking us to determine? They are asking us to determine the quality factor Q. What is the relation between quality factor, bandwidth, F0? Okay, this seems to be, it's like a series RLC, all are parallel series. Okay, for a RLC circuit, okay, it seems like all the elements are series RLC circuit. What is the quality factor? Or any circuit, relation between quality factor, bandwidth, nothing but F0 by bandwidth. That's all. Whether it is series circuit or parallel circuit. Suppose in this diagram, if they given RLC values, if they have given RLC values, then how to calculate for series circuit? 1 by R root L by C. For parallel circuit, R root C by L. But here they are not given the constants, they are given the bandwidth and the resonant frequency. Therefore, this simple job is done. This is 150 kilo divided by 600, or this is 1 by 4 times, 1 kilo by 4, 1000 by 4, 250. Okay, this is the quality factor for the given circuit. What is the unit of quality factor? No units. Why? Quality factor, how it is defined? 2 pi some factor into energy stored by energy dissipated. What are the storing elements? Energy stored in inductor or capacitor. There's a peak energy stored in inductor or capacitor divided by the average, okay, or energy dissipated by resistor at resonance. That's all. Okay, that's why no units. Let's move on to next question. Okay, here an inductor having a quality factor of 60 and in series with a capacitor having a quality factor of 240. The overall quality factor of the circuit is, okay, here inductor, okay. When you will have a quality factor, I told right now, quality factor, how it is defined? Energy stored by energy dissipated. Okay, energy stored by energy dissipated. It's not an ideal inductor, it's a practical inductor. Any practical inductor can be considered something like this. Okay, this entire thing nothing but the inductor part. Okay, that entire thing nothing but the inductor part. Some resistor series with an inductor. This entire nothing but a inductor itself. And capacitor, okay, in series with a capacitor. How a capacitor will be? Capacitor, practical capacitor parallel with some resistance. Capacitor parallel with some resistance. Okay, for this circuit, okay, what's the information they given? Actually, this is a inductor, practical inductor, choke coil. Okay, choke coil or iron core coil, practical inductor. This is a practical capacitor. Okay, right. And here for this circuit, what is the expression for quality factor of series RL circuit? Omega naught L by R. What's the quality factor for this circuit? 1 by omega naught CR. Okay, parallel circuit omega naught CR. This is the thing. Right now these two, okay, for RL circuit here, this is RC circuit. For parallel RC, this is the thing. Okay, right. Right now both are in series here. Okay, we can verify the total quality factor. You can get it like this total quality factor nothing but that Q1 into Q2 by Q1 plus Q2. If you read in the terms, you can get like this. Okay, what is the quality factor given? 60. This quality factor is given as 60. This quality factor is given as 240. Therefore, this 60 into 240 divided by 60 plus 240. This value 60 into 240 divided by 300. This is 5 times. Okay, 240 by 5 nothing but 48. This is a quality factor Q, 48. That's all. What is unit of quality factor? No units. Okay, let's move on to next question. Okay, this mod, something like mod 2 and a mod 5 counter when cascaded together results in dash counter, they are asking. Okay, here this is a mod 2 counter, mod 5 counter. This question came from digital electronics. Okay, it's a mod 2 followed by mod 5. Mod 2 followed by mod 5. When a mod 2 counter followed by mod 5 counter, it acts as simple mod 10 counter, that's all. That's all, simple, it acts as a mod 10 counter. Even if you cascade mod 5 by mod 2, mod 5 followed by mod 2 also acts as a mod 10 counter only. Okay, answer for this question, simple, 10 is the right answer, that's all, mod 10 counter. Next question, the maximum clock frequency in megahertz of a ripple counter with each flip-flop having a propagation delay of 20 nanoseconds is? Okay, simple question. What is given? Ripple counter. Okay, 4-bit ripple counter, no need of any operation also. Ripple counter. Okay, this is a ripple counter, and here 4 bits are there, right? What is the clock frequency in megahertz? The maximum clock frequency megahertz of 4-bit counter, each flip-flop having a propagation delay. This is a TP, propagation delay of each flip-flop nothing but 20 nano, 20 nano, 20 nano. Okay, each flip-flop 20 nanoseconds. This flip-flop also 20 nanoseconds. Okay. Okay, flip-flops, ripple counter, right? Overall propagation delay. Okay, overall propagation delay nothing but n into TP. That's all. 4-bit. Okay, required 4 flip-flops into each 20 nano. This is 80 nanoseconds. Okay, propagation delay of each flip-flop is 20 nano. Therefore, it's a ripple counter. Okay, overall propagation delay nothing but 20 nanoseconds. What's the maximum frequency of operation then? Okay, if you required f, this f equal to 1 by the total. This is 1 by 80 nano. or this is a again right 10 power 9. Okay, nano when goes to numerator becomes 10 power 9 by 80, or 1000 into 1 mega 10 power 6 divided by 80. What is 8000 by 80? 125. 125 megahertz. That's the maximum clock frequency, F maximum. The maximum clock frequency, okay, nothing but 125 megahertz. Done. Let's move on to next question. An LTI system is shown in figure. G of s equal to 100 by s square plus 0.1 s plus 100. The steady state output voltage to the input x of t is given as y of t equal to a plus b sin 10t plus theta. The values of a and b, okay, will be dash. Okay. This question you can do with the help of signals, controls, as well as networks. Okay, anything you can take. We did the steady state values, right? Okay. How the system is given? Actually, here some system is there. Okay, this is some system G of s. For this system, we are giving the input x of t, we are getting the output y of t. Right now, they are asking us to determine the steady state output. Okay, the steady state output for the given system we got like this: a plus b sin of 10t plus theta. Then they are asking what is the value of a, what is the value of b, and they are given the system function g of s. Okay, this is g of s, they are given as 100 by s square, okay, plus 0.1 s, 0.1 s plus 100, and input is given as, okay, the input x of t, this is the input given, 1 plus 0.1 sin 10t. Okay, 1 plus 0.1 sin 10t. Okay, everyone, let us see that g of s. What is that g of s given? G of s. This is g of s. Tell me what is the g of s function here? 100 by s square plus 0.1 s. 100 by s square plus 0.1 s plus 100. Okay. Just I am copying the input also. And what is the input given? 1 plus 0.1 sin 10t. Okay, x of t is given as 1 plus 0.1 sin 10t. Sin 10t. Okay, everyone, notice one thing. What are the different frequencies of operations present in the circuit here? Different frequencies of operations. Here we have two sources, okay, two inputs. This is one input DC, another input is 0.1 sin 10t, right? Two inputs. And here this is working at which frequency? This is working at which frequency? This is working at a frequency omega equal 10. This is working at a frequency omega equal to 0. Two different frequencies of operations. This omega equal 10 radians per second. Okay, this is DC. This omega equal to 0 radians per second. 10 radians per second, 0 radians per second. Okay, I am showing the shortcut here how to calculate the steady state response. Okay, y of t. First of all, you calculate g of j omega. G of j omega. What is g of j omega? Just put replace s by j omega. This is 0.1 s, 0.1 into s. S means j omega plus 100. Okay, this is 100 by, what is j square minus 1? Minus omega square plus j into 0.1 omega plus 100. Okay, or I am separating the real terms and imaginary terms in the denominator. 100 minus omega square plus j into 0.1 omega. This is g of j omega. You do one thing. Okay, what are different frequencies of operations in the circuit? One is 0 radians per second, another is 10 radians per second. Calculate this transfer function at two different frequencies. Okay, what is g of j0? g of j0. Okay, this is 100 by j0. This is 100 minus 0 square, okay, plus 0, j into 0, or this is 100 by 100. What is this 100 by 100? This is 1. Okay, here this magnitude is 1, angle 0, or this can be written as at this 1 at an angle 0 degrees, g of j0. Similarly, let us try to find this function at omega equal to 10. Okay, g of j10. What is g of j10? This frequency I am calculating. Substitute here. This is 100 by, okay, 100 minus 10 square. Wherever I have omega, replace by 10. J into 0.1 into 10. Okay, or this is 100 by, this is 100 minus 100, 0, plus j. This is 0.1 into 10, 1. Okay, or this is 100 by j. J here if you j is a rectangular form, if you convert into polar, this can be replaced by 1 at an angle 90 degrees, or this is 100 by 1 at an angle 90, or this is 100 at an angle minus 90 degrees. This is the transfer function at 10 radians per second, omega equal 10. Okay, right? Everyone, right? Simple thing. What we are trying to do is, what is the input here? Input x of t, nothing but 1 plus 0.1 sine of 10t. 1 plus 0.1 sine of 10t. Okay. And what is the transfer function at 0 radians per second? 1 at an angle 0. Okay. This is g of s. G of j0, we got 1 at an angle 0. What is the g of j10? G of j10, okay, we got g of j10 as 100 at an angle minus 90. 100 at an angle minus 90. That's all. Okay. Okay, what is the output? Okay, just I am telling the shortcut here. Please, everyone, what is the output y of t? If you want y of t, just write these things as it is. 1 plus 0.1, okay, sine 10t. Everyone, first of all, write like this. This input I written as it is. 1 plus 0.1 sine t. 1 plus 0.1 sine 10t. Okay, right now what we are trying to do is, let us multiply by the transfer functions. Okay, transfer functions. What is the transfer function for j0? Okay, 0 radians per second, 1 at an angle 0. Multiply the magnitudes. If any phase is there, add the phases. Okay, no phase term. What is the transfer function for j equal 10, 100? Magnitude is 100. Multiply the magnitudes. Subtract or add the phases. Okay, this at an angle minus 90. Okay, at an angle minus 90 degrees. That's all. Okay. Therefore, overall transfer function then y of t. What is the y of t? This is 1. 0.1 into 110 sine of 10t minus 90. That's all, finished. Okay, right now if you go back to the question, what they given, okay, what they asking there, y of t equals something like a plus b sine of some 10t plus some phase. What is the value of a? What is the value of b? They are asking here. What is the value of a? What is the value of b? What is the value of a? If you compare here, a equal to, answer, a equal to, what is the value? A equal to 1. What is the value of b? 10. That's all, finished. I am going back to the options here. Okay, they given output a plus b sine 10t plus theta. They ask you what is the value of a, what is the value of b. We got a as 1, b as 10. Okay, a as 1, b as 10. Option B is the right answer. Done, completed. Okay, let's move on to the next question here. Next, move on to the next question. Okay, some system they ask in nonlinear or causal. Okay, this question belongs to signals and systems. What is the information given? Some signal input to the system is x of t, output of the system is y of t. and the system function, okay, output x y of t equal to x into e power t, okay. Then they are telling what is the system, whether linear non-linear or causal non-causal, okay. Here if weighted inputs, weighted sum of inputs giving the weighted sum of outputs, then the system is said to be linear, okay. So here if I give the input a into x of 1 of t plus b into x2 of t, okay, a into x1 of t plus b into x2 of t, whether I am getting the same kind of output here, tell me, okay, whether I am getting the same kind of output here, okay. If I check a into y1 of t plus b into y2 of t, okay, here y1 of t, y2 of t, just substitute the inputs here. Here input is x of t itself, x1 of t, nothing but here x of e power t plus b into x2 of e power t, that x of e power t, okay, this is nothing but e power t, this also x of e power t, I am giving x1 of e power t, x2 of e power t, okay. You are getting the same outputs, yes or no? Weighted sum of outputs, inputs giving the weighted sum of output, then the system is linear system only, linear, okay, easy, okay, easy. Here when the system will become non-linear, when you will get a square terms, okay, then becomes a non-linear, cube terms, okay. Right now this is a linear system only, okay. Just discuss about causal non-causal. What is causal non-causal? Present outputs depends on the future inputs, and then the system is called causal. Here y of t is nothing but x of e power t, okay. Just check one value, y of 1. What is y of 1? X of e power 1, okay. This is something like x of 2.72, 2.72 something, y of 1. Now here itself common sense tell me, right now here this is 1 is a present value, then 2.72 becomes a future value. Present output depends on future inputs, okay. Then system is non-causal. Present output depending on the future inputs, then the system is non-causal, okay, non-causal. Therefore system is linear non-causal is the right answer, linear non-causal. Clear? These are definitions. From definitions you can answer these questions. Let's move on to next question. Let an input x of t, okay, 2 sin 10 pi t, 50, okay, 5 cos 15 pi t, 7 sin of 42 pi t, 4 cos of 45 pi t is passed through an LTI system having an impulse response h of t equal to from 2 sin 10 pi t by pi t into cos of pi t, okay. Right, here some sine term here, this is some cos term here, okay, this is some 2, okay. It seems like a 2 sin theta cos theta, okay, 2 sin a cos b, okay, 2 sin a cos b. Then it can be written as sine of sum plus sine of difference, sine sum plus sine difference, okay. Sine of what is term 10 pi t plus 40 pi t plus sine of a minus b, okay, sine of a plus b, sine of a minus b, okay. This is the sine of 10 pi t minus 40 pi t, okay. Here you got sine of 50 pi t, 50 pi t plus sine minus theta minus sine theta, this is sine of 30 pi t, okay, sine of 30 pi t, okay. This 2 sin theta cos theta, change it to something like sine 50 pi t minus sine 30 pi t, sine 50 pi t minus sine 30 pi t, okay. There is a divide by pi t also, pi t, okay, right. This is a h of t, we are seeing the h of t system function. This h of t, okay, this h of t like this, something like a sine 50 pi t by pi t, okay, 50 pi t by pi t minus sine 30 pi t by pi t. Okay, here it seems to like suppose this seems like sine pi t by pi t sinc function. This is some sine pi t by pi t, seems like a sinc function. Okay, suppose if you assume this is h1t minus h2t, okay, h1t actually is a sine pi t by pi t sinc function here. Okay, sinc function, this is a sinc function. Okay, if you have any sinc function, okay, sine pi t by pi t, okay, it seems like a sinc function like this, something like a sinc function. This is also sinc function. This is h1 t. Similarly, h2 of t, this is also a sinc function. Okay, it seems like a sine 30 pi t by 30 pi t, you can write this. Okay, and can you please tell me what is the Fourier transform of sinc function? Okay, if you write the Fourier transform sinc function, you will get a, what you will get? You will get a rectangular pulse. Okay, some rectangular pulse signal. This is the thing. Okay, something like this. We are getting a rectangular pulse. What is this one? Actually, pi 50 pi. This is from minus 50 pi to plus 50 pi. Okay, this is in omega domain. H1 of omega. Okay, for this one Fourier transform. Similarly, this is between minus 30 pi to plus 30 pi. 30 pi. This is also omega, H2 of omega, j omega. Okay, H2 of omega or H2 of j omega. And here H1 of t minus H2 of t, okay, that results in, okay. Then what is this H1 of t minus H2 of t? H of omega, okay. This H of omega, j omega equal to H1 of j omega minus H2 of j omega, okay. And if I subtract one from the other, okay, that results in something like this. You are getting some pulses, okay, between 30 pi to 50 pi, 30 pi to 50 pi. This is minus 30 pi to minus 50 pi. Clear everyone? That's all. Okay, right. Let's go back to the question. This is the h of t. Okay, h of t. Notice here. Then h of j omega we plotted right now with respect to omega domain. We got like this. Okay, plus 30 pi to 50 pi. Minus 30 pi to minus 50 pi. Now see the question again. Let an input, this entire input is passed through an LTA system having impulse response. The output of the system is, okay, just check the inputs which can pass through that filter. That's all. Okay, right now tell me frequencies. You just identify the frequencies which we can pass here. Okay, here this omega is 10. Here omega is 15. 10 and 15 can't pass. Okay, wrong. Okay, here omega is 10, 45. Okay, 10 only can pass, 45 can't pass. Okay, here 40 to 45. Okay, 40 to 45 all are between this range, it can pass. Okay, here 15, 42, 15 cannot pass, only 42 can pass. Okay, this cannot pass, only this can pass. This cannot pass. Okay, only this can pass. As a whole, this not answer. Entire input not passing whole. Therefore, answer for the given question is option C is the right answer. Only these frequencies can pass 42 to 50, 45 between the range. They are between the range 30 pi to 50 pi. Okay, right. That's all. Basic. Okay, basics, signal basics. Let's move on to next question. Okay, let a causal LTA system be governed by the following differential equation. Y of t plus 1 by 4 dy by dt equal 2 into x of t, where x of t and y of t are the inputs and output respectively. The impulse response, its impulse response is, they are asking what is the impulse response, nothing but system transfer function they are asking, that's all. Suppose the system is x of t, input is x of t, output is y of t. The input is x of t, okay, output is y of t, system function is h of t, okay. And then the relation between x of t, y of t is like this, okay, differential equation. We will do something here simple, we will solve by using Laplace transforms. It's quite easy, Laplace transforms. If I take Laplace, let Laplace transform x of t be x of s, y of t be y of s, okay. Then what is the differentiation of d by dt of y of t? D by dt of y of t, what is the differentiation? S into y of s, s into y of s, that's all. Let us apply Laplace transform for this network here, for this equation. Then this y of s plus 1 by 4 into s into y of s equal to 2 into x of s, that's all done. Separate y of s terms here, this y of s into, okay, 1 plus 1 by 4 s equal to 2 into x of s. Then what is this y of s by x of s? Y of s by x of s. This is 2 by 1 plus s by 4, or this is 2 by 4 plus s by 4, or this is 8 by s plus 4. Okay, we got the system function h of s. Okay, this h of s. Okay, 8 by, right. Then let us try to find the h of t. H of t. This h of t nothing but Laplace inverse of h of s. Okay, Laplace inverse of 8 by s plus 4. Laplace inverse of 8 by s plus 4. Okay, then if I take 8 outside, okay, Laplace inverse of 1 by s plus 4 nothing but e power minus 4t u of t. Since they given the causal LTI system, okay, write in terms of u of t. Therefore, choose the right option, 8 into e power minus 4t u of t. Option A is the right answer. That's all, finished, done. Option A is the right answer. Simple question. Let's move on to next question. Okay, op amps given, right? Then this question belongs to analog circuits, right? The current gain I out by I in the circuit with an ideal current amplifier given below. Okay, what is the current gain I out by I in the circuit with an ideal current amplifier? Okay, this capacitance is given as CF, this capacitance is given as CC, this is current is I in, this current is I out. They are asking what is I out by I in the circuit. Okay, everyone, right? Let us start. This is the op amp infinity, something represented is an ideal op amp. Ideal op amp, okay, if this is at ground, this also at ground itself, virtual ground, okay, this also virtual ground. Okay, right now what I am trying to do is let us convert the given network into S domain. Here, this capacitance can be written as 1 by S into CF ohms. This capacitance can be written as 1 by S into CC ohms. Right now what I am trying to do is, let us try to write the expression for V out here, V out. What is this V out here? V out. V out. Okay, with respect to ground I am trying to write. What is this V out with respect to ground? V out plus minus. Okay, let us write the V out with respect to ground. Here, notice here, virtual ground, okay, virtual ground. No current, and this ideal op amp, no current flows into the op amps. Since internal impedance is infinity, okay, no current flows here. Here also 0 amperes, no current flowing into the op amp. Whatever the current here, the entire current will be flowing like this, IN like this. Okay, just apply nodal analysis here, nodal analysis. Nodal analysis at 0 volts, nodal at 0. Okay, 0, okay, this current leaving plus IN, plus IN, 0 minus plus 0 minus V out by this impedance, okay, 1 by S into CF equal to 0. You apply nodal here at this node, okay, 0, this current leaving plus IN, 0 minus this voltage by this impedance, or this IN, okay, minus V out, this is S into CF equal to 0, okay, reciprocal. Done. Or this IN equal to, we got this IN as V out into S into CF. That's all, finished. Okay. And if I see this output part of the circuit, how this output part of circuit looks like, notice here. This one, this is the output node V out. This output, okay, and this is a capacitor here, C, or if you convert into S domain, this is CC ohms. And this voltage nothing but V out here, V out, and the current flowing through this one nothing but I out, okay, current flowing through that one nothing but I out, this current nothing but I out, current flowing through that one nothing but I out. Okay, then tell me the expression for this V out expression, voltage, Ohm's law, current into impedance, okay. Right, this I out, what is the expression for I out? Current, okay, V out, I required the expression for V out, okay. What is the expression for V out here? Ohm's law, I out into impedance 1 by Z into S into CC. Or from here, what is I out then? V out into S into CC. Okay, let it be equation 1, let it be equation 2. Question what they asked us to calculate, calculate the I out by I in, okay. Take the ratio 1 by 2, take the ratio 1 by 2, everyone. What is the equation 1 divided by equation 2? Equation 1 divided by equation 2 implies I in, or equation 2 divided by equation 1. Okay, equation 2 divided by equation 1 implies this is V out or I out by I in equal to, okay, V out into SCC divided by V in into SCF. Okay, okay, this is not this is also V out only. Okay, this is also V out, and anything getting cancelled here, right? Here this V out getting cancelled, S also getting cancelled. Then what is I out by I in? I out by I in, tell me what is this value? CC by CF. CC by CF, that's all, CC by CF. I'm going back to the slide. Okay, 1 second. What are the options given here? Okay, here this is minus CF by C, minus CC by CF, CC by CF, minus CF by CC, CF by CC. Okay, please choose the right option here. CC by CF, I out by CC by CF. Option C is the right answer. Option C is the right answer for this question. Done, everyone? Next question. Everyone, notice here. For the circuit shown with an ideal diode, the output will be, they are asking, output will be, simple question. For the circuit shown below, the ideal, with ideal diode, the output will be simple. Okay, what they are asking us to determine here, okay, ideal diodes are given. Okay, suppose this voltage I am applying here plus, okay, this is minus this voltage, okay. Then this diode, this voltage is plus, okay, anode side, this is cathode side, okay. This is negative, anode side, this is cathode side. Okay, and here anode voltage for the first diode, top diode, anode voltage more positive, then this acts as a forward bias. Okay, in forward bias, diode acts as a short circuit. This here also cathode voltage less, negative, connected to negative. Okay, this also forward bias only, forward bias. Okay, this diode also acts as a short circuit. Okay, how this circuit look like? Okay, this is the way how it look like. Okay, whatever the R it may be, whatever the input I am giving, okay, we'll get the same output here, V out. Okay, this V out equal to V in parallel. Whatever the input I am giving, the same thing will be given out, V out. Right? That V out equal to V in. Okay, suppose if I give negative voltage, okay, here itself, if I give negative voltage, what happens? Tell me. If I give negative voltage, what happens? Tell me. If I give negative voltage here, negative, I am talking about this voltage, negative. If I give negative voltage here, this is a minus, right now this is plus. Right now this is minus, this is plus. Right now anode voltage negative, cathode voltage positive. Okay, anode voltage negative, cathode voltage positive. Diode will become reverse bias. Here cathode voltage positive, okay, more. Here also diode will becomes reverse bias. In reverse bias, both the diodes are reverse bias, ideal diodes, reverse bias acts as an open circuit. Okay, this is the circuit. And what is the V out you are going to get here? Not connected to V in, not dependent. Okay, 0, 0. For positive voltages, okay, for this negative voltages, like this. Then try to answer. Finally, this V out equal to V in for V in greater than 0, V out equal to V in for V in less than 0, this is wrong. V out equal to minus V in, wrong. V out equal to minus V in, wrong. Okay, this is the right option. This V out equal to V in for positive values of input voltage. Completed? Everyone. Next question. What the information given? The output impedance of a non-ideal operational amplifier is denoted by Z out. Okay. The variation in the magnitude of Z out with increasing frequency in the circuit. Actually, for this diode, for this op amp, they given the information like output impedance is Z out. Right now, they kept this feedback. Okay, output is fed back here like this, and this becomes a voltage series. Okay, voltage series feedback. In voltage series feedback, output impedance reduces. Okay, this Z out. If you want to find the new Z out, this Z out decreases. Okay, Z out by 1 plus A beta. Z out by A1 plus A beta, where A is the gain of the amplifier. Okay, and beta, this is the feedback. It's a unity gain feedback. This beta equal to 1, and this is Z out. Okay, by 1 plus A itself. This is Z out. Okay, the output impedance of a non-ideal, since it's a non-ideal, okay, op amp, okay, this output impedance is not infinity. Some Z out, and this configuration is a voltage series configuration, then Z out decreases. Okay, 1 by 1 plus A beta, and the gain of this non-ideal op amp is not infinity here, some high value only, something order of like this. Okay, and this value decreases like this, 10 power 6, order of 10 power 6 gain with respect to frequency. Okay, gain of this op amp with respect to frequency, something order of 10 power 6. And since this A term is at the denominator, okay, this is the with feedback I am talking, this is ZF, Z0 with respect to feedback. Okay, that Z out by 1 plus A gain. Okay, initially it's constant, and as frequency increasing, gain decreases. Then here, how the Z out curve will be? Okay, Z out. or log of z out or log of z out. Okay, if I plot here with respect to log of frequency. Here, notice here, if this frequency, notice here, if this gain, yes, gain is constant, here this also constant only. As this gain decreases, okay, this also decreases and becomes constant there. You choose the right option. Okay, this is not right, this also not decreasing. Okay, this is not linearly increasing, this is increases then constant. Okay, you should know the feedbacks, different types of feedbacks to solve this question. Next question, the steady state output V out of the circuit shown will, okay, shown will be, it saturates at minus VE or saturates at VDD becomes equal to minus 0.1 becomes equal to 0.1. Simple question, just we have to concentrate on this word steady state. Okay, steady, not study, it's a steady state. Okay, steady state, for the steady state output. Okay, one thing I told you, steady state, what is the behavior of capacitor? Steady state open circuit. Okay, if you only capacitor present here, open, this capacitor steady state open. Then how this op amp look like? This diagram right now, this is plus, this is minus. Okay, this is plus 1 volt, right? This is R2. Okay, this is V out. This is VDD plus VDD. This is minus VE. Since steady state, capacitor behavior, open circuit behavior, okay, right, this is circuit that is valid, that's all finished. Right now, whether any feedback in the system right now in steady state, this is a normal frequency of operation at steady state, no feedback. Then it becomes a open loop okay, no closed loop, okay, it's an open op amp, no feedback, nothing. Op amp, normal op amp, that's all. And we know one thing, ideal op amp, no current flows here, okay, no drop across this resistor, 0 volts. Then right now tell me what is the voltage here? This is 1 volt, therefore this voltage also 1 volt. What is voltage here? No drop across this resistor, this is 0 volts. Simply tell me which terminal voltage is more, negative terminal voltage or positive terminal voltage? Negative terminal voltage more compared to positive terminal voltage. Then it saturates, yes or no? Output, when negative voltage more compared to this one, what is the output? You will get minus VE. That's all, finished. Answer, saturates at minus VE is the right answer. Done. Clear everyone? Right, excellent. Let's move on to next question here. Next question. For an ideal MOSFET biased in saturation, the magnitude of the small signal current gain for a common drain amplifier is, okay, ideal MOSFET, okay, it's ideal MOSFET, this is a MOSFET. Biased in saturation, okay, the magnitude of the small signal current gain in common drain. See here, MOSFET also we have different configurations. You can consider gate as a common, you have common gate configuration. You can take source as common, you have common source. Or another configuration, common drain, you can take drain as common. Right now, here they are taking a drain as common, okay. Notice here, I am representing, this is a source terminal, this is a drain terminal, okay, this is a, sorry, right, this is a gate terminal, this is a source terminal. These are the terminals. I can configure in any way, okay. Right now I am showing like a drain is a common, okay, since they are asking the common drain configuration. Okay, right now for this common drain configuration, if a drain is considered as a common here, okay. Right now tell me, where you are taking the output here? Output we are taking from source, okay, output we are taking from source. Where you are applying the input here? Input applied to the gate. This is called common drain configuration. Common drain configuration. And for this common drain configuration, what is the input current? Ig. Okay, input current is Ig. What is the input current in a common gate? Gate, actually normally gate terminal is isolated. Okay, silicon dioxide insulating material is there. It's a zero current flows. What is the current flow in the source terminal? Source. Some current will be flowing here, source. And what do you mean by, okay, current gain? Current gain. Current gain nothing but output current by input current. Output current by input current. What is the output current here? Is. What is input current here? Ig. Okay, some Is, some value will be there, divided by Is divided by 0. What is something by 0? Infinity. The current gain in a MOSFET in common drain configuration is infinity. That's why in MOSFET configurations always we will try to solve other parameters like voltage gains, okay, input impedances, output impedances, all these parameters. The input current to the gate always equal to 0. Simple question. Okay, next question. The transfer function of a real time system H of S given as, okay, As plus B by S square plus Cs plus T, where A, B, C, D are positive constants. This system cannot operate as, okay, right, I told in the class also, filters, okay, simple filters. Transfer function is given. When a transfer function is given, just substitute S equal to 0. Substitute S equal to 0. Then this is A into S, right? A into S 0 plus B by C S square 0 square plus C into S plus D, or this is B by D. Done, finish. What is H of infinity? Substitute infinity. Okay, here numerator degree 1, denominator degree S square 2. Okay, denominator degree is more compared to numerator. If you substitute here, you will get 1 by infinity. Okay, you will get 0. It seems to be like it is allowing low frequencies, not allowing high frequencies. Okay, allowing seems to be like not allowing high frequencies. Okay, not allowing high frequencies to pass through it, only allowing the low frequencies. Okay, and then definitely it's allowing only low frequencies, not allowing high frequencies. Definitely it should be a low pass filter. Low pass filter. And we know another thing, low pass filter also acts as an integrator. Yes or no? It's a MSQ question, multiple select answers. Okay, it's allowing only low frequencies, not allowing high frequencies to pass through it. Okay, the system cannot operate as they are asking. Okay, actually the system operating as low pass filter and integrator. Okay, it cannot operate as high pass filter. Okay, answer is it cannot operate as high pass filter and cannot operate as band pass filter. We are allowing only low frequency to pass through it. Okay, they asked the question like it cannot operate as, okay, that's why it cannot, it operate as low pass filter, integrator, it cannot operate as high pass filter, okay, band pass filter. Next question. Okay, see the question for the first order stable system, the magnitude, Bordeaux plot, Bordeaux magnitude and Bordeaux phase plot is shown below. Okay, then which of the function is correct? Okay, and we have discussed many times. Okay, it seems to be like we know first order stable system, right? First order stable system, magnitude constant. Okay, for which filter or first order circuit the magnitude will be constant? Definitely it's a all pass filter. Or if you are listening for the first time, notice here, suppose if it is a low pass filter, first order low pass filter. First order low pass filter, how the first order low pass filter will be? Something like 1 by S plus 1. Okay, 1 by S plus 1, or suppose if you have any doubt, we'll clear it. Here this is the low pass filter. How the low pass filter look like? So this is the low pass filter. This is R ohms, this is C farads. If I convert this into S domain, this is nothing but 1 by S into C ohms. And what is the trans function V naught of S here? This is Vi of S. This V naught of S equal to, okay, voltage division rule 1 by SC divided by R plus 1 by SC into Vi of S. Okay. Then what is V naught of S by Vi of S? V naught of S by Vi of S equal to something like 1 by 1 plus S into RC. If I keep RC equal to, let RC equal to 1, okay, 1. Then this seems like 1 by 1 plus S. That's the H of S for a low pass filter. Okay, for a low pass filter, I got something like this. This question not about this low pass filter. Okay, suppose if I talk about first order high pass filter. First order high pass filter, how it look like? So this is the first order high pass filter. This is the C farads. This is R ohms. This is V naught of T. Okay, this is Vi of T. V naught of T, Vi of T. And here, if I convert it into S domain here, 1 by SC ohms, this becomes V naught of S. Tell me what is V naught of S? Voltage division rule. This V naught of S equal to R by R plus 1 by S into C, Vi of S. Then what is this V naught of S? This is SRC divided by 1 plus SRC into, okay, Vi of S. Now then what is this V naught of S by Vi of S? This is the thing, H of S. If I substitute RC equal to 1, if RC equal to 1, then how this transfunction look like? H of S equal to S by 1 plus S. This is a first order high pass filter. First order high pass filter. Here you have a one pole, here we have a 0 at origin, pole at -1, something like that. Okay. If I talk about here, they given magnitude under phase plots of something. If I talk about the all pass filter, the all pass filter transfunction will be something like S minus 1 by S plus 1 or 1 minus S by 1 plus S. 1 minus S by 1 plus S. Okay. Or if I talk this is 1 minus j omega by 1 plus j omega. Magnitude, what is the magnitude of this H of j omega? This is square root of 1 plus omega square divided by square root of 1 plus omega square, or this is 1. The magnitude function is 1, constant. For all frequencies, magnitude function is constant. And the phase plot. If I draw the phase, what is the angle of H of j omega? Okay, angle of H of j omega equal to angle of this one minus tan inverse of omega divided by, okay, tan inverse of omega. Minus tan inverse of omega by tan inverse of omega. Okay, or this is nothing but minus theta 1 divided by theta 2, theta 1 minus theta 2 minus 2 tan inverse of omega. This is the angle. If I substitute the different values of omega varying from 0 to infinity, at omega equal to 0, this angle is 0. When omega equal to 0, angle is 0 degrees. When omega is infinity, omega tending towards infinity, this 2 tan inverse of infinity, tan inverse of infinity 90 degrees. Minus 2, this reaches minus 180 degrees. Okay, that's why I notice here. At 0, this is 0, and as frequency increasing, this reaching, right, this is the all pass filter. From this one, you try to answer the question. Okay, all pass filter, if I plot this one, you have the S domain. You have a 0 at 1 and you have a pole at -1. Okay, so here options 1 left hand side pole and what right hand side pole at same frequency, right? Okay, 1 left hand side pole, 2 right hand side, zeros wrong, 2 left hand side wrong, 1 left hand side 0 and 1 left hand side pole at same frequency. Both are same options. 1 left hand side pole, right hand side 0 at same frequency, 1 left hand side 0, okay, 0 wrong. Therefore answer A is the right answer. A is the right answer. This is the information. Just I discussed how the first order low pass filter, first order high pass filter will be. Okay, right. Let's move on to next question. Control system. The damping ratio in a damped network damped network frequency at a closed loop system as shown in figure are denoted by zeta and omega. Okay, damping ratio zeta and damped frequency omega n shown. The value of zeta and omega n they are asking. What is the value of zeta? What is the value of omega? Okay, simple here. You try to reduce this blocks. If I go to this network here, it's a G of S, unity gain, okay, and this is plus here, this is minus here, negative feedback. Then what is the trans function of that inner block? G of S. If I assume this is G of S, okay, this is H of S equal to 1. G of S by negative feedback 1 plus G of S into H of S. Okay, this is 10 by S divided by 1 plus 10 by S into 1. Okay, or this is 10 by 10 plus S. For this block can be replaced by 10 by S. 10 by 10 plus S. Again, this 10 by 10 plus S and 10 by S, how they connected to each other? Cascaded. This entire block 10 by 10 plus S and this is 10 by S. 10 by 10 plus S cascaded with 10 by S. Okay, then entire function is 100 by S into S plus 10. Okay, right now this entire, this one and this one I written like this. This is the trans function 100 by S into S plus 10. Now, okay, this is this entire function is nothing but 100 by S into S plus 10. 100 by S into S plus 10. Right now, again, this entire thing is 100 by S into S plus 10. This is a negative feedback, again plus minus here, and unity gain H of S equal to 1. Okay, H of S equal to 1. You consider this as G of S. Okay, again, what is that? Y of S by R of S. Y of S by R of S. Okay, G of S by 1 plus G of S into H of S. G of S is nothing but 100 by S into S plus 10 divided by 1 plus 100 by S into S plus 10 plus into 1, or this is 100 by S into S plus 10 divided by S into S plus 10 plus 100 divided by S into S plus 10. S into S plus 10, S into S plus 10 getting cancel each other. Okay, therefore this is nothing but 100 by S square plus 10S plus 100. You got the trans function, output trans function by input, Y of S by R of S. Okay, let's go back. 100 by S square plus 10S plus 100. Okay, we got this Y of S by R of S. This Y of S by R of S, we got like 100 by S square plus 10S plus 100. 10S plus 100. This seems like a second order equation, like S square plus omega n square by 2 zeta omega n into S plus omega n square. Okay, compare the coefficients here. What is the omega n square value? Okay, if you compare the coefficients, tell me what is the value of omega n square? Omega n square equal to 100. Then what is the value of omega n? 10. 10. If I compare the quotients, again 10, this 2 zeta omega n, 2 into zeta omega n, okay, equal to 10. Then 2 zeta into 10 equal to 10. This 10 cancel. What is 2 zeta? 1. Then plus what is the value of zeta then? 1 by 2.5. For this network, they are asking what is the value of zeta, what is the value of omega n. Okay, zeta is 0.5, omega n is 10. Option B is the correct answer. Okay, option B is the correct answer. Done, everyone? Let's move on to next question. Okay, see this question. Nyquist. Okay, this question also belongs to controls only. The open loop transfer function of a unity gain negative feedback system is given. Okay, open loop transfer function g of s given. The Nyquist contour in the S plane encloses the entire half of the S plane. Okay, right half of the S plane. A small neighborhood around the origin in the left. Okay, contour. This is a contour given here. This is a contour, and this is S, two poles here. One is here at origin and at -1. This contour. Okay, this contour is including that pole at origin. Contour is including that pole at origin. Okay. Shown the number of encirclements of -1 plus j0 by the plot of g of s corresponding to the Nyquist contour is denoted as n. Then n is equals to. Okay, actually here we know one thing. Number of encirclements, nothing but p minus z. P minus z, number of encirclements. Okay, they are not given the your Nyquist plot, nothing. Here open loop poles. Okay, this is 1 by s plus 1. One pole is in the contour, right? How many poles in the contour? Okay, this poles equal to 1. Open loop poles in the contour 1. What is the Z is giving? Z is always giving the information about the closed loop poles. If Z is 0, the system is stable, perfectly stable. But if I see this G of S system 1 by s into s plus 1. Okay, this system is always stable. Closed loop system also always stable. Closed loop system also always stable. Also always stable. Always stable only. Okay, always stable only. Then if I calculate Z, any closed loop poles in the RHS? No. Z always equal to 0. Then if I see this information, then n equal to p minus z. Open loop poles 0. That system, given system is always stable. Okay, or p. Open loop poles in the contour 1. This is 0. Then this is 1. Therefore, number of encirclements of the contour with -1 plus j0 with the Nyquist plot will be 1. If n is positive, encirclements are in the anti-clockwise. If n is negative, it will be in the clockwise. That's all. Answer n is 1 is the right answer. No need to draw anything here. Okay, basic things. Okay. One question from EMF given like this. A vector is defined as E bar equal to 2x into I bar plus 5y into j bar plus 3z into k bar. Find the value, okay, of this is a del, okay, not delta, del bar, okay, value of volume integral del bar dot E bar dv, okay, where V is the enclosed volume. Okay, del dot E bar, okay, gradient we need to find. Divergence, okay, del dot, okay, del, how del is defined? Dou by dou x ax cap or I bar, okay, dou by dou x I bar I cap plus dou by dou y j cap, dou by dou z k cap dot, okay, 2x I cap plus 5y j cap plus 3z k cap. Okay, right, and we know one thing. What is I bar dot I bar? I bar dot I bar is 0. J bar dot j bar 0. Sorry, I bar dot I bar 1. I bar dot I bar 1. J bar dot j bar 1. K bar dot k bar 1. Okay, and I bar dot j 0. I bar dot k 0. Okay, right, so that okay, I dot I, okay, 1 only dou by dou x, okay, del dot E bar, you will get dou by dou x 2x plus dou by dou y 5y plus dou by dou z 3z. Okay, I got like this 2 plus 5 plus 8. This value is 13 plus 2, 15. This is a del dot E. Okay, then volume integral del bar del dot E dV. Okay, this is volume integral 15 dV. This dV nothing but dx dy dz only, dx dy dz. And if you see this one, x varying from 0 to 1, y varying from 0 to 1, z varying from 0 to 1, it's nothing but a unit cube only, unit cube. What is the area of a unit, volume of a unit cube? 1. Okay, 15 into integral 0 to 1 dx, integral 0 to 1 dy, integral 0 to 1 dz. Okay, this is 1 1 1. Therefore, okay, this is 15 into 1 into 1 into 1. Answer 15. Done. 15 is the right answer. Finished. Okay. 2 plus 5 plus 8. 7 plus 8. 15. 2x, 5y, 3z. Okay. 2 plus 5 plus 15. Okay. Options here typed, I think this is 15. Option D is the right answer. Typing mistake. Okay. 15 is the right answer. This is 15, not 5, 15. Let's move on to next question here. Consider the magnetic, okay, this is magnetic field, okay, intensity h bar. This is given x square I cap, x square y square j cap, okay. Value of j bar, current density, asking at x equal to 1, y equal to 2, take y equal to 2, z equal to 1, okay, round off to 1 decimal point. Do it here. Okay, right, 1 second here. Here, 1 second, notice here, 2, 5, this is 3 only, this value, previous problem, this is a 2 plus, this is a 2 plus, this is a 5 plus, this is 3 only, 2 plus 3 plus 5, this is 10, okay, this is not 15, this is 10 only, 10, this also 10, answer, this is 10 only, 10 only, okay, 10, I thought they say 8. Okay, consider the magnetic field intensity h bar equal to the value of j bar at x equal to 1, y equal to 2 and z equal to 1, round off to 1 decimal place. Okay, right here they given h, they are asking us to determine j. Okay, what is the relation between h and j? Del cross h equal to j bar. Okay, Ampere circuital law. Okay, Ampere circuital law, del cross h equal to j bar. Therefore, we need to find the curl. How to find curl in the cross? Okay, this is I bar, j bar, a bar, dou by dou x, dou by dou y, dou by dou z, and this is x square, this is x square y square, this is x square y square z square. This is the curl. That's all. Okay, therefore let us expand this one, I cap into these two, I cap into, okay, dou by dou x, dou by dou y, dou by dou y into x square y square z square minus dou by dou z into x square y square. Okay, right. Similarly, expand this one, minus j into dou by dou x, dou by dou x, okay, into x square y square z square minus dou by dou z into x square. Okay. Next, similarly plus k bar into these terms. Okay, plus k bar into, tell me, plus k bar into dou by dou x x square y square z square minus dou by dou z into x square, close the bracket. Okay, dou by dou z into z x square. Okay, here this I bar, this I cap into this value where dou by dou y. Okay, only y square term is there, you differentiate that one, and x square z square are constants. X square z square into this becomes 2y. Okay, next here differentiation of x square y square, no z term here, this is 0. Next, minus j, this is differentiation of x. Okay, this term with x. Okay, only 2x, it becomes 2x. This is 2x y square z square, and this is differentiation with respect to z x square term. Okay, this is 0. K cap. Okay, k cap, this is 2x, only x term, differentiate 2x y square z square, and differentiation of x square with respect to z, 0. We got the curl of these things like this. Okay, then what is the j bar? I am writing here. Okay, j bar we got like this: I cap into 2 times x square y z square. Okay, minus j cap into 2x y square z square. What is k cap? Plus k bar into, this is 2x y square z square. Okay, and they given the values here, they are asking us to calculate the magnitude of j bar. Okay, first let us calculate j bar at x equal to, okay, at this point 1 comma 2 comma 1. Therefore this is I cap into, this is 2 into 2 4 minus j cap into, here y square 1 1. Okay, y square is 4, 2 square into 2 8 plus k cap into, okay, y square y square, okay, again a 2 square into 2 8. This is the j bar. Okay, what is the magnitude of j bar? What is the magnitude of j bar? Magnitude of j bar, this magnitude of j bar equals square root of 4 square plus 8 square plus 8 square, square root of, okay, 64 64 16. Complete that one. Sixty-four 128 plus 16 144. What is square root of 144? 12. This answer is 12 amperes per meter. The right answer, j bar. That j bar for the given question, nothing but 12 amperes per meter is right answer. That's all. Very good. Simple here. In this question, no innovativeness is required. No innovativeness. Simply traditional method to calculate the curl. They given h, how to find j. You should know the relation between the h and j. Curl, okay, del cross h equal j bar, that's all. Right. They given one question. A long conducting cylindrical body having radius b is placed on z axis, and j bar equal to ja r cube z cap for r less than b, and r is a radial distance. The value of h bar for r less than b. Okay, what is the information they given? It's a cylindrical body, some cylindrical body. Okay, some cylindrical body like this. If I notice here, top view, something like this view, having a radius b, okay, is placed on a z-axis. Is placed on z-axis. Radius is b. This radius is b. Okay. Where r is for r less than z. Okay, this radius is b r. This is the information given. Radius is b. Radius is b. Okay. Where r is the radial distance for r less than b. Okay, inside this entire thing, what is the, where r is the radial distance? They are asking j bar. Okay, right. What is the h bar? They are asking. They are given the j bar. H bar they are asking. Tell me, if you know j, how to calculate h? Here also again same as previous question itself. In the previous question h bar given, they asked the j. Okay, in this question they given the j bar, they are asking us to determine the h bar. Do it here. Do it, everyone. Okay, again here also let us use the Ampere circuital law. Okay, what is Ampere circuital law? Ampere circuital law. Ampere circuital law or Ampere's law. Okay, that del cross h equal to j only. Del cross h equal to j. Okay, or line integral h bar dot dl. H bar dot dl. Okay, this is nothing but surface integral j bar dot ds. Surface integral j bar dot ds. Okay, j bar, here this j bar given in the az cap, right? J bar, since j bar is given in ja r cube az cap, okay, unit vector along z direction given, then you consider the surface area along the z direction. What's the ds? Here this system is similar to rho phi z, or here they given the notation r, then this system is nothing but r phi z, cylindrical coordinates r phi z, or some of you might study like rho phi z, a cylindrical coordinate system. Cylindrical coordinate system. Cylindrical coordinate system. Okay, rho phi z or r phi z. Okay, small incremental distance along r dr, small incremental distance along z dz, small incremental distance along phi r d phi. Okay, we required in this one. Okay, then ds, different types of surface elements. Here you have dr dz along phi direction, dr r d phi the z direction, or dz r d phi, okay, along a r direction. Different types of surface areas. Since they given us the h j bar along z cap, okay, you take this small incremental area. Okay, this ds nothing but r dr d phi along az cap. R dr d phi along the az cap. That's all finished. Simple. That's all. Selection of this ds is important. That's all in this question. Okay. Okay. Right. Line integral will substitute later h bar dot dl. Okay, equal to surface integral. Okay, j bar dot ds. J bar they given ja r cube az cap dot ds. ds, this is the r d theta dr d phi. Okay, r dr d phi along z direction. That's all. Az dot az 1, az dot az 1, and here this phi varying from 0 to 2 pi. This phi varies from 0 to pi, and r varying from 0 to r only. Okay, as a function of r, we are trying to find this one. Or this itself, right? I'm right RHS. Okay, az dot az 1, r into r cube, r power 4. Okay, this is a dr d phi, and this phi varying from 0 to 2 pi. Okay, and r varying from 0 to r. And here integral d phi itself. Okay, 0 to 2 pi. Okay, separating that one, 0 to 2 pi. This is a d phi. Okay, you will get 2 pi. Okay, integral 0 to r. Okay, ja r power 4 dr. Let us evaluate this one. Okay, this is a surface integral, line integral h bar dot dl. H bar dot dl. Okay, I am evaluating this one here. Let us evaluate that one. Let us evaluate that one. Line integral h bar dot dl equal to, okay, so ja r power 4 dr. Ja r power 4 dr, r varying from 0 to r only, and you have a d phi, this phi varying from 0 to 2 pi. Okay, that's all. Right, here this is phi only, substitute the limits 0 to 2 pi, you will get 2 pi. This is ja r power 4. What is integral of r power 4? R power 5 by 5. Substitute the limits 0 to r. Okay, as a function of r only. And here this is cylinder. Okay, you notice here like this. This radius is r. Okay, radius is r only. Circumference. Okay, what is circumference of that one? Around this one, h bar dot dl. This is closed integral h bar dot dl. This becomes 2 pi r. 2 pi r. Okay, therefore this is 2 pi r equal to into h bar equal to, this is 2 pi, this is ja into r power 5 by 5. Okay, this 2 pi getting cancelled, or h bar equal to ja, this r, that r power 5. Okay, r cancel, this is ja r power 4 by 5. This is the h bar. This is the h bar. You check the options here. What is the options given? ja r power 4. This is the right answer. That's all. Okay, here also no simple thing, you should know the relation between j bar and h bar. That's all. No complex things, nothing. Okay, simple things, straightforward questions. Okay, let the probability density function of a random variable. This is also from signals and systems. Okay, you should know this property. Okay, what is the area under the curve? F of x dx from minus infinity to plus infinity. Minus infinity to plus infinity, probability density function dx equal to 1. That's all. If you know this property, we can find this one. Or this minus infinity to infinity, f of x, a into e power minus 2 mod x dx equal to 1. And e power minus mod x, okay, minus mod 2x, mod x is there, na? Mod x is an even function. That's why this limits I can change to 2 times, okay, 0 to like this, a into e power minus 2 mod x dx equal to 1. Find that integral. That's all simple. This is a 2a, writing outside e power minus 2 mod x by mod 2, okay, minus 2. Substitute the limits 0 to infinity. This equal to 1. Okay, 2a into e power minus infinity minus e power 0 divided by minus 2 equal to 1. Okay, or 2a into 0 minus 1 by minus 2. This equal to 1. Okay, 2 cancel, minus minus cancel, a equal to 1, we got like this. What they asked us to determine, let the probability density function of a random variable x is given as, okay, then the value of a. What is the value of a? 1. That's all. Simple question. Simple question. Okay. Something, okay, networks, 3-phase system. Okay. What they given? 2 balanced 3-phase loads shown in figure. 2 3-phase loads. Here, this is Z2, 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 Z2. This is star load. Okay. This is Z1, this is Z1, this is Z1 is a delta load. Okay. All are equal. That's why balanced 3-phase. How many networks given? 2 balanced 3-phase are given. Okay. Loads as shown in figure are connected to a 100√3 volts 3-phase main supply. Okay. Given Z1, they given Z1 as 18 plus J24, Z2 as 6 plus J18. Then the ammeter reading in the amperes is they asking. That's all. Simple question. Seems to be complex thing. We'll do one thing here. Okay. What we'll do is we'll convert this star to delta. Convert star to delta. Convert this star to delta. Okay, if I convert this star to delta, this is a Z2. This you will get like this. If I convert this Z2, okay, this is Z2, this is Z2 into star, I will get a network like this. And we know one thing, balance star to delta, impedance increases by 3 times. That's why this, what is this impedance? This is 3Z1, 3Z2. This also 3Z2. This also 3Z2. This is the first step we did. Okay. And right now, how this network look like right now? This is Z1 is there, and parallelly you have 3Z2. Similarly, here also Z1 is there, parallelly you have 3Z2. Here also Z1 is there, parallelly you have 3Z2. Okay, Z1, this is 3Z2. Z1, 3Z2. Z1, 3Z2. Okay. Here this is an ammeter A is given. Right. This is a circuit right now. Okay. Right now, okay, let us try to calculate this Z1 parallel with, both are parallel, right? What is Z1 parallel with 3Z2? What is Z1 given? What is Z1? Z1 18 plus J24. What is Z2? Actually 6 plus J8. 3 times of Z2, 3 times of Z2 nothing but 18 plus J24 ohms only. Okay. And Z1 and Z2 both are 3Z2 or both are same. Then what is Z1 parallel with Z3Z2? Okay. This one parallel to this one only. 18 plus J24 parallel to 18 plus J24. If you are assuming impedance as Z, okay, here we got Z parallel to Z. What is Z parallel to Z? Z by 2. Z parallel to Z nothing but Z by 2 only. 18 plus J24 parallel to 18 plus J24. This is 18 plus J24 by 2. What is value? 9 plus J12. 9 plus J12 ohms. Okay, right now this parallel combination 9 plus J12, 9 plus J12, 9 plus J12. Nine plus J12 ohms. All are 9 plus J12. Clear? Right now, when you convert this one, this network, we got like this. is ammeter. Center is a delta network only. Okay, and this phase voltage given as 100 root 3 volts. 100 root 3 volts. They are asking us to determine this line current, ammeter reading, line current. Okay. Okay, this is 9 plus J 12 ohms. Okay, this also ohms. 9 plus J 12 ohms. This also 9 plus J 12 ohms. Okay, right. Here we can do one thing. Here this voltage from here also, this is the voltage itself, 100 root 3. Please tell me what is phase current, I phase. What is the phase current here? Phase current in each branch, phase current. Okay, phase current. How to calculate phase current? That voltage 100 root 3 divided by impedance 9 plus J2, J12. Okay, what is the magnitude of this phase current here? What is the magnitude of the phase current? Magnitude of phase current, I phase, equal to 100 root 3 divided by magnitude square root of 9 square plus 12 square. What this value? 100 root 3 divided by square root of 81 plus 144 square root of 225, 15. 5 20s, 5 3s. 20 by 5 root 3. 20 by 3 root 3, or this is 20 by root 3 itself. So many amperes phase. And if you notice here, we calculated phase current, right? This is line current. The line current is flowing across the ammeter. They are asking what is the reading of the ammeter. Okay, then what is the relation between phase current and line current? Okay, what is the relation between phase current and line current? Tell me. This line current, nothing but root 2 3 times of phase current. This root 3 times of 20 by root 3. Okay, root 3 cancel. This is 20 amperes. That's the answer. That's all, finished, done. 20 by root 3. That's answer. Very good, everyone. 20 by root 3 into root 3, 20 amperes. Okay, that's all we have. These are the memory based questions that students have sent to us, and we tried our level best to clear all your doubts after your gate. And official gate paper questions, okay, maybe coming out in maybe in 1 week or 2 weeks. Okay, all the best. Be calm, try for best in your life. Happy success to all of my students, lovely students. Okay, thank you, bye, see you all. Jai Hind.